Good afternoon. Welcome to the PARC Forum. My name is Sharon Tyler, and I'm standing in for Kathy Ching, who's coordinating this series of forums on behalf of EXOFT. Next week's forum will feature Charles Russell from the Webster Research Center. He will speak on electronic color documents and the 1992 SIGGRAPH proceedings. This week, we're pleased to present Dr. Adele Goldberg from Parcplace. Dr. Goldberg earned the PhD in Information Science from the University of Chicago and has held research and teaching positions at Stanford University and the Pontificia Universidade Católica of Rio de Janeiro, Brazil. During her 14 years at PARC, she served as manager of the Systems Concept Lab, leading the R&D team that designed Smalltalk. From 1984 to 86, Adele served as president of the ACM. She's authored numerous books, articles, and papers. In 1987, Dr. Goldberg received the ACM Systems Software Award, and she has also received PC Magazine's 1990 Lifetime Achievement Award for her significant contribution to the personal computer industry. Please join me in welcoming Adele Goldberg.
I was originally going to title this talk, Is There Life After Xerox? But I understand Chuck Geschke did that already when he came back from Adobe after a couple years being away. What I was planning to do today is three things, is to tell you what Parcplace is today and tell you from a technical point of view what we've done over the last few years to take a research result that we took out of PARC into the commercial sector. And then, as the third item, launch really into more technical details of a new product that we just started shipping a couple months ago called VisualWorks, and do a demonstration of that. David Leibs from Parcplace Systems is here with me. David is an old Zeroid as well. He and a number of his colleagues from the Dallas Development Center were the first four or five members of Parcplace Systems. We had transferred them up here in the late 80s as we were negotiating with Xerox to form Parcplace Systems. Parcplace Systems, in terms of its vision, is clearly an extension of the work we were doing here at PARC. It's a software company, and the idea is quite simple, which is to build software that allows programmers to create interesting applications that remove the barrier between people and computers. It's sort of the emphasis that people are important rather than machines. Machines may be interesting, but they're there to help people. Our focus has been primarily on programmers at different levels, and we've been very interested in supporting the full development life cycle. The technology base for what we're doing is object-oriented technology. We spent a lot of time in the early years evangelizing object technology and trying to convince people that just because it was objects didn't mean it was bad. Now we spend most of our time trying to convince people just because it says it's objects doesn't mean it's good. And you really have to take a look at what the issues are in introducing the technology into an organization. Make sure that you have the right kinds of tools and organizational structure, and especially that you're prepared to deal with the learning problems, the analysis and design methodology problems for finding those objects and mapping them into the actual implementations. For a lot of you, I know you're familiar with the technology. It's an old habit, probably generated out of the Smalltalk early days, that you want to build something, you just sit down and you start building it. I hope it doesn't surprise you that as part of the commercialization, we've had to put a lot of effort into backing off and trying to help people who don't just live and breathe objects to figure out what the right structures, what the right models are, what the right architectures are for their systems before they launch into programming. So we worry about the problems of learning, analyzing, implementing, and testing. Big emphasis, of course, on reusing and creating frameworks that people can specialize. Frameworks in our product line have more to do with the horizontal support for user interface creation and information modeling. We wanted to make sure that the productivity expectations of objects were available by assisting in the process of porting across platforms. And as I'll show you, the Parcplace Smalltalk emphasis has been on 100% portability. And then finally, really helping people understand that it's not enough to just reuse in order to get initial fast development, but you have to be able to know what the reuse is, know who the reusers are, and be prepared for the long-term maintenance. So a little history. We officially left Xerox in March 18th of 1988. Now, for the historians in the crowd, March 17th, 1988 is the day that Apple sued Microsoft and Hewlett-Packard. And the result of that was that Parcplace got its picture in the Wall Street, or I did in the Wall Street Journal, because the claim was, of course, that that was a silly lawsuit given that it was all based on small talk in the first place. That may have been the case, but the lawsuit just settled, as you know, recently, and had been a slight nemesis of Parcplace for the time because of my own involvement in being the only Xerox small talk team member who never worked at Apple. So it was a strange position to have found myself in. We shipped our first small talk product in July of '88. We also got very involved in the C++ community. The reason for that should have been obvious. We're real strong believers in architecture and the support that objects bring to that architecture. Have a good knowledge of the kinds of tools that aid in understanding object-based systems and a good understanding of useful libraries, and felt that for C++ to be successful and for people to understand the benefits of object technology, those tools, those environments were going to be important there as well, and that we would have something to contribute. We raised, I think, about $11 million so far, and we're done raising money now forever, she says, except in the public market. We're a profitable company. We're well over 100 people. For those of you who follow the market, PowerSoft, which is going public now, is a little bit behind us in quarterly revenues. So we're at about a $24 million run rate right now. Not bad for a group of researchers that didn't quite know what they were doing when they stepped out in that real world. We completed our first profitable year then last year, and then this year we took the money we had in the bank and we acquired two companies, or at least technologies from two companies. Solbern Computer Company, which was a Spark clone, had a software development group, software business unit that had done some excellent work in designing visual components library for C++, and a product we call Object Builder for constructing user interfaces based on that library, Smart Editor. And we acquired them in the early fall. We also acquired, which I'll explain a little bit later, technology that raises the tools level in the Smalltalk world for interfacing object worlds to relational databases. This is a technology called Infoware, which was a group we spun off and then we just bought back. It's kind of fun to do. So as I said, we're a little over 105 people. We have engineering center in Boulder, Colorado. That's where the C++ team is partially, the rest here in Sunnyvale. We have an engineering center in Portland, Oregon. That's a dozen people all working on a Smalltalk project. We have a subsidiary in Munich, and then we have distributors around the world as well as our own direct sales offices in, let's see if I can get this right, New York and Washington, Dallas, Seattle, here in Sunnyvale, and in, I think that's it, I got it right. So we've kind of gotten ourselves spread around the world pretty fast. We had started out in the Pacific Rim with a partnership with Fuji Xerox, which continues today, although not exclusively anymore. So we have a couple of distributors in Japan. Our target market, as I said, is primarily programmers. So we have three product lines. We have a product line that's focused on the C++ and C programmer. We have a product line focused on the Smalltalk programmer, and then a bunch of engineering services. From day one, we knew that this was going to be an educational process and put together a good training team, a professional services team that does a lot of mentoring and support of our customers. So with a direct sales force knocking on the door of very large corporations, we back that up with people who can go out and give them direct training and mentoring as they start bringing object technology. The kinds of programmers, however, we deal with varies depending on the language. This is a map that I drew which sort of says, here's what's going on out there. If you look at programmers today, it's not, hey, there's those guys over there and beg them to make changes. There's a whole different layering of who the programmers are in the corporations. The corporations then, working on a network with lots of information sources, may go from a programming focus of systems programmers, although in the commercial sectors like the investment banks on Wall Street, for example, or the insurance companies, they don't tend to call themselves necessarily systems programmers. They'll call themselves competitive edge programmers. They're the ones who absolutely have to have access to every little detail of everything because they're trying to squeeze the blood out of any performance or any modeling capability they can. And then they move forward to the people who, you start moving in the circle towards people who are more tied to the business. But of course, the way things are working now, it all comes back where they all have to know the business. When we first started in business, I used to give a lot of talks where the audience were all programmers. And I would say to them, okay, how many of you are programmers? And most of them would raise their hand. And I'd say, well, keep your hands up if you're any good. Now, what percentage of this audience would keep its hand up? What percentage of the audience do you think kept its hand up when I used to ask this? No, it's interesting. Lotus, they kept their hands up, all of them. And I said, oh, just a minute here. This is before they've been so late with 1, 2, 3. And I said, aren't you the guys who are a little bit late? And they said, oh, no, we're the Magellan team. They're not allowed to come. But most of the time when I'd ask the question, I'd get about 4%. And sometimes nobody would keep their hand up. And a lot of it, except they look at one person in the room, and that was the key person they relied on. And then we'd end up, I think, hiring them, and so I had to stop asking the question. What was going on there, of course, is in those days, which is 4 or 5 years ago, when you'd say, are you good? The measurement of good had to do with, can you create the result that's desired so it's running fast enough, using the right amount of speed, and delivering it on time? And since very few people could take credit for being on time, they were keeping their hands down, as you'd expect. But increasingly, there was becoming this problem where they didn't know quite what it was they were supposed to deliver. And the guys who were keeping their hands up, when I'd say, well, what makes you good? More and more they were saying, we know the business. So the transition out there, as we head into the 90s, is not an isolated systems programming team of people who read the computer science literature, but people who truly understand the business. And so there's kind of a partnership that goes on where the old data administration people are more information administration, worrying about the information models or object models of the company, worrying more of these problems of what is the shared repository. And they negotiated a lot with these guys who kind of try it out, kind of worry and try it out. So you have to start worrying about tools that transcend these levels of access to the system and pull around to the power users and end users. But inserted in that is another new class of, not a new class of people. These people have been there all the time, the chief financial officers, the accounting managers, the human resource managers, the systems managers. We're always in these companies. But more and more, as they started using spreadsheets and doing simple two-dimensional, linear constraint-oriented systems, they started realizing that they didn't have to go ask for help anymore, or at least they believed they didn't. They can just go program the computer as well. So as we're moving into the 90s, we're seeing a big emphasis of these competitive edge programmers creating frameworks that represent the business process being delivered down to the information managers who are modeling their business, programming through more constraint, declarative-oriented languages, and expecting to have clear access all the way down between very static databases on the mainframe, static databases in the relational world, even static object databases, but not as heavily oriented as we're still on the DB2 and on the hierarchical and network databases on the mainframe. And more trying to have a client-server model where they're after some kind of computation service. So we start having to worry about what kinds of tools and environments you give to these kinds of people. And what we've been doing is focusing our C++ product family more on the systems programmers and business programmers who are really doing the user interface design. And as a result, we use the word ObjectWorks to refer to the programming environment for that systems programmer, for a professional programmer. Object Builder in the OI library, which we acquired from Solbern this fall, then provides that kind of graphical construction. but it still expects you to have fairly deep understanding of C++ in order to set up the callbacks for any kind of button push or any kind of widgetry on the screen. We have a process debugger for good tracing of the variables and the dynamics of your C++ program. And then part of the strategy is, along with ObjectWorks, there are libraries and smart editors that we call object kits. And in this case, it's we remarket some other people's stuff. I'm going to spend most of my time focusing on Smalltalk, though, because a lot of people looked at our products and started seeing us announcing C++, and they said, they got wise, they gave up on Smalltalk. 50% of our product revenue, which was over $1 million in December, of that $1 million was all Smalltalk product. And then, of course, on top of that is doubling our revenue between C++ and our services. So we've made a business out of Smalltalk. We've managed to mainstream Smalltalk along with our partners and other vendors who sell Smalltalk. And we do it with a number of products. ObjectWorks for Smalltalk then is focused on that system competitive edge programmer. We ship out full sources and we sell sources for the implementation of the system, allowing that competitive edge programmer to make changes at any level of the system. ObjectWorks does not assume that it's going to be on a client graphics. It allows them to build information models on the servers. And on Wall Street, we have a large number of investment banks who specifically use Smalltalk to do the modeling of the portfolios out on a server, and then multiple trader workstations running the client base. We have a number of object kits I'll say some more about, and then VisualWorks, which we're going to demo today, and then a lot of drivers to hook up to relational and non-relational databases, such as the ones listed here. I want to go through this pretty quickly because I want to spend most of our time on the actual VisualWorks content. Let me speak to the portability problem, because this gives a hint of the kind of work we had to do. The idea of portability is not that you take your C code and recompile it and hope it compiles and hopes the compilers have the same bugs in them. The idea of portability is that you take a fully running system that is compliant with the expectations of that host system, pick it up, put it on the other platform, and it takes care of all the problems associated with living on that new platform and just works. Clearly the idea is productivity here is both speed as well as lower cost. If I'm maintaining this one application, but it happens to run across all of these workstations that are kind of the combinations of these processors, the Motorola-based processors, Intel-based processors, there's a bug here for sure, and all the RISC-based SPARC and MIPS and RIOS and the PA systems are the ones we've done. In fact, the only ones that we really haven't done yet are the 64-bit ones, which are coming up, the Alpha chip and whatnot. So we spend a lot of time worrying about the change in processors. We worry about the operating systems combined with the windowing systems, have an object engine that I'll describe in a little more detail, and then a bunch of modeling objects. And then above that line is our whole programming environment that you use to develop your application. Your application then deploys at this level right above the base across all of the supported workstations, and we guarantee 100% portability unless you decide to use something which we also support that host provides that nobody else does. Example, if you're on a Unix system and you lose sockets, you're certainly not going to be running sockets off your Mac or off your PC until WinSock actually becomes real. But as the vendors start providing more and more services, we make all of that available. The VisualWorks that we're going to show you adds another layer above this. The idea was, of course, very simple. It says, if I'm doing sophisticated interactive graphics, I'm going to have a very sophisticated package that understands the visual widgetry, understands all the layout. Learning how to program that is hard and has nothing to do with whether you're a good programmer or a novice programmer. It has to do with the fact that the concepts behind sophisticated multi-layered layout is just simply hard. So what you want to be able to do is say, never mind, you could see it on the screen, just paint it, just lay it out, and we'll take care of the rest. Now, so that's one set of it. The second set of it says, yeah, but how all those widgetry hook up together and maintain their dependency together, and how they hook up to the application logic that gets me out to the databases or out to my information models, which may be servers on the net, that's all complicated hookup as well. Help me automate that. So we provide a application framework which gives the first default layer of that then can be refined to get out there. And that's what we're going to show you today. So we extend the portability that I showed you with 2 more layers. And that the 2 layers then is to provide an isolation layer for the database that says, and this is our customer requirement, I'm going to write SQL and embed it in my Smalltalk and then squirt that out through whatever drivers are available. Some drivers act as middleware. EDA SQL is a product from Information Builders Incorporated in New York, and it acts as middleware so that if you send it any SQL message, it will try and figure out what its correspondence out is to the actual database. But of course, it's an isolation layer we're providing, not independence, because if you send an SQL message that Oracle doesn't understand but Sybase does, and you send it to Oracle, there'll be a problem. So we just provide the API for that layer, and then we're coming above that with the independence layer. And then we provide 2 more things, what we call a policy interface for the look presentation, so that you can sit at the one machine and rehearse what it will look like on all the other machines. One of the other productivity problems our customers have is that they don't quite control what machines their applications will be deployed on. Some of them have thousands of users of an application, and those thousands of users are worldwide. And some of them will be on PCs, some on Macs, some on Sun, some on DEX, some on HP, and so forth. And every one of them has some difference, peculiarity that they would have had to check out by having a laboratory full of every machine and then configuring to it. So we provide essentially a re-implementation of the key aspects of all the machines so that they can rehearse across it. Just one thing on the object kits for Smalltalk. The 2 things that have become important is that Smalltalk is clearly no longer its own world. We sit in the host Windows system, calling on host facilities, working with the host operating systems and executing to the machine code of whatever processor we're on. And that means that we also have to interoperate well with other languages. And so one of the things that we've done is created a object kit that lets you sit there and say, here's my C procedure interface, create the Smalltalk object stubs for me so that I can call to the C programs and call back. Of course, what it's really doing is calling to that C interface, and other languages that compile and can be stored in those kinds of, the right header files can also play in that kind of wrapping technology. The next 5 slides that I put together was to say, look, everyone used to ask me, what's the difference between a research result and a product? And one strong feeling we had is, of course, the research result is the thing that you can always throw it away and start over again. And that was kind of the whole Smalltalk group's mentality, is we really didn't want anybody using any of the stuff because then we couldn't throw it away. So now that you're commercial, you don't get to throw things away. Every release has a backward compatibility issue. But we had to start stepping through, and I believe if it isn't 100%, it's about 98% of the code we ship today is brand new since we started. If that weren't the case, you should be pretty worried about our customers. I was pretty worried back in 1985 when I first started haranguing Xerox to do something, because Xerox's, some of their groups were shipping very interesting applications. The Analyst Workstation is still one of the more sophisticated applications that I've seen built with full object-oriented technology. But they were shipping it on complete research results. Object engines built out of research, and they were scaring me because they were shipping it to government agencies who were using it for their daily work. And somehow it just didn't quite feel right. Now they're shipping it on a robust engine, and it doesn't break, and it all makes a little more sense to me. That object engine that we rewrote, we had a couple of missions. The first one was that we would be fully compiled. Smalltalk, at least our Smalltalk, is fully compiled on all of the workstations. However, you don't compile it. Basically, it's what we call a lazy machine code generator. You have an intermediate representation. That representation sits on top of this layer here. When you need to use a part of the system, it will compile it down to the machine code and then cache that. It never does it again. You never notice it. You never notice any burp or any waiting. If it then has a cache of 8386 code and you move it to other 8386 machines, we stick with that. But if you pick it up and put it on another machine and it's a spark, it notices the difference, flushes the cache, and starts recompiling again. Because we recompile and not the people moving it from machine to machine, they don't have a configuration release expense on them. Nor do they have people who have to know all that stuff. And that, of course, gives us a couple things: much faster execution speed, better space efficiency, and then the binary portability that we're looking for without having to have an interpreter. Another thing we had to do was design an entire new memory manager. This memory manager is unusual in a number of ways. It's what you might think of as a hybrid memory manager. We basically segregate our objects according to age. Young objects, what I call midlife objects, and old objects are ones that require permanent or immortality. And then we apply very different algorithms, very different approaches to the management of those segregated objects depending on what they are. So we'll use a mixture of generation scavenging, incremental interruptible garbage collection. So you can actually have a policy to say how often you want it to start garbage collecting and for how long it should happen, but it always bows to user events, so it will always stop. In the old days here at PARC, there was the famous little icon, which was a garbage can, saying, just a minute, I'm the computer, I'm in charge here, I have to go clean up the mess you've made. And that doesn't show up anymore, and that's good. And then, of course, an old-fashioned mark sweep is still in there as well. The big reason why we redid the whole object engine and rewrote it all was because we needed to have a portable architecture, because we were fairly confident that despite the fact in 1987 I was told there'd be only 2 operating systems and 2 processors we'd ever have to worry about, I was pretty sure that wasn't going to happen. I lived at PARC too long with people who like to invent those things, and we were making it easier to do that. So, of course, we can port to different machines very fast. We run today on 11 different platforms. When we shipped VisualWorks this fall, and we had 7 platforms out at the time, we delivered VisualWorks on every platform immediately. And we're one of the very few software companies ever to do that. So even if our customers didn't believe or want portability, we sure did, and it's really made a difference in the size of our engineering teams and the cost of our business. A lot of other things we did. We wanted to start creating layers of independence. If you're going to be on multiple operating systems, that means multiple file systems. There was a design of a new class library of uniform I/O that you program to, and then you have complete independence of the file system. We had, of course, to admit that Xerox didn't get in charge of the look and feel of the world, and that were going to be lots of different host Windows systems, and we would have to comply with more conventional imaging approaches. So we redid our entire imaging model, threw out all the bitmap stuff that was in there, and redid the entire class library accordingly. And that gave us graphics code independence across all the machines. We also had to put a layer of classes in there that defined how you talk about window managers. But as you move from the Mac, using the Mac window manager, onto the PCs and Windows, or onto the Sun and OpenLook, or most of the other Unix systems with Motif, it immediately converts to whatever the window manager of choice on the host is. We did a whole lot of series that we call policy interfaces, so that you're always programming to policy. This is very much in line with what Bob Balzer at ISI has been screaming about for as long as I've known him, which is probably 15 years, which is you don't program and generate code, you program specification. You describe what you want, and when you need it, you go put it into the form for execution. And more, we've been taking that route. So policy interfaces are ways of saying, here's the kinds of color palettes I want. Here's the description of the fonts I want. Here's the kinds of visual widgets I want, an action button or a checkbox or whatever. And here's my view of what I need in the memory manager. And based on that policy, when it's time to execute, the system figures out what the good match is to the underlying host system. We didn't do a lot of changing to the Smalltalk language itself. That's kind of coming up over the next couple years, since there's now a proposal before ANSI for ANSI standards. That should stall any progress for a while. Our biggest change that we're planning to do the language, regardless, and to propose to the standards, of course, is to start having a clearer segmentation of the namespace in the system, so we can have a base ability for dynamic loading and unloading, and that work is in progress now. We've added a sophisticated exception handler in there. A lot of people would say to us, oh, Smalltalk's perfect for prototyping, and I thought it was perfectly awful for prototyping because you couldn't signal that you were incomplete. A prototype is something that's incomplete. And the worst thing you could do to somebody who you're testing an idea out is to give them something that's going to crash all over or be real slow. Because then they're going to tell you, I don't know, your idea is okay, but it was running so slow, or when I tried to do something, it crashed. So prototypes have to degrade gracefully, and they have to run just as fast as any production system. In fact, prototyping systems tend to have to be, in my eyes, more robust than some of the product systems. You have less time to check things out. So we put the exception handler in. We also redid all the graphics and user interface libraries, as I said before. I'm on the board of the OMG. We've been participating with them to understand the distributed shared object world problems. A number of companies have been doing bindings of Smalltalk to the object request brokers, and actually in a couple of weeks a major vendor is going to be announcing a beautiful product which is Lotus Notes-like, all based on the visual works that we're going to show you. We've done a lot of work in both product lines on visual navigation and better ways of understanding source code. The ObjectWorks for C and C++ product is written in Smalltalk. And provides a nice visual navigator that's coordinated with the source code debugging and online help. I grabbed just a couple of pictures of it just to give you a hint of that, which was basically, it's a user model that says, pick a focus of attention and then attach to that focus the perspective of how you want to look at it and its neighborhood. So I may pick as a focus of attention a particular member function or a particular class or a particular file. And then I may say, gee, the perspective is who calls on this or what does it call on? And then I'll get a graph to look at it. And then I could attach to some other part a perspective for reading the source code and have a connected browser that shows me the source code, and I can simply move this perspective around in order to change the focus down here. So we get a lot of interesting visual direct manipulation type pointing to look at the various parts of a system. It's a drag and drop system so that there's a whole menu full of different perspectives that you can have for editing, asking questions about usage, asking questions about who's the client and who's the server of a particular element, and then be able to have a focus of attention, like the list here, and drag the different perspectives down. So we were doing experiments and then out to product for the C++ community, and we're going to bring all this back to the Smalltalk community. The debugger works with the same style, and then the help system, which is online, has two parts to it. Most programmers I know, whether they're Smalltalk or C, C++, COBOL or Fortran or whatever, don't like to document. I think that probably rings true here as well. And when you ask them why they don't like to document, they say it's a silly waste of redundancy. The system, it's in there already. Look at the code, it's all documented. Sound familiar? And what they're really saying is, if you could just have some kind of filter, some browser on the structure, and let me explore it dynamically, I'll have better documentation of what's going on. But the one piece of documentation I, programmer, am willing to write is what role these particular objects or these particular functions were meant to play. So we use the same kind of navigation on the online help system. And in the Unix system, we then convert Unix man files into these correct formats for being able to do the browsing. So a lot of that work is happening, and all that graphical stuff will come back to the Smalltalk world. We also had to worry about the bridges to and from other systems. Smalltalk obviously wasn't going to live in its own world. Nobody, nothing lives in its own world in a networked environment. So as I said, we built the C programming object kit for the call and callback interface. We also built what we call the Fusion database isolation for the embedded SQL. And then the first year at Parcplace, when we started in on the database problem, we started a project that ended up being called InfoWare, and really has this object lens, this notion of creating a persistent object world where you talk about objects and you send messages to containers of objects for updating and inserting and deleting, and it automatically generates the SQL out to the relational database. automatically lets you extract the forms and create the images on the screen, and automatically lets you navigate over the relational database. And to do that, you have to not retrieve everything, but have a notion of proxies. And to do that, you have to absolutely know that for any retrieval, if you've retrieved it before, it's the identical object. And that means that you have to have knowledge of the primary and foreign keys in the relational database. And so this technology that we started, I started getting worried that it was a little bit too much research. We spun the little group out. They got separate funding. They were researchers. They did get it done. We've bought it all back, and so we're integrating it now with VisualWorks to bring it out as a product. I think that's a lovely way to do things, and it was kind of fun after 1 year to be on the other side of that spin-out table. And then the last slide about what we had to do, given that our target were large corporations, then we knew we were going to have large corporation culture problems, or as we say in business, culture opportunities. And so the issue here was to understand, not just for object technology, but for any new technology, what do you have to do to be ready to bring it in the door so that people understand what they have to learn and you can help them learn, but also where the real cost is. A lot of people equate objects and reuse. They think that from the day they get started, everything will go faster. They can just reuse all these libraries, combine them together. It's really magic. It's the most remarkable example I've seen in the last decade of a strong belief in magic. I certainly think Philippe Kahn has contributed to that belief, but not I guess this year he hasn't. One of our goals is to go in, and I really literally go into the chief information officer of these companies and I say, look, it's going to be hard. Here's what you're going to have to do. And it's going to cost you. If you're really going to do reuse and it's going to make a difference to you, it's strategic reuse, which means that you're not going to buy it from the outside. I'm probably one of the few people out there who doesn't believe very strongly in a large public market for objects alone. And I qualified that carefully. But basically that they are strategic, they are products, they have to be prepared as products. So we've done some major project case studies and have been endlessly, as some of you know, working on a book that to explain what we think works and doesn't work, and should have that out sometime this year. And as a result of doing all that, you really start getting into process model and what works and what doesn't work. I've had people accuse me of sounding like some DOD contractor, which was pretty scary, because around here they used to, accuse me of living in a fairy world. Maybe they're the same. So we got very heavily into understanding what methodology is, and started looking to see what was the problem with all the books. There's lots of books on object-oriented methodologies coming out now, and why they weren't working. And they weren't working because they all make one assumption. They assume you already know what the objects are, and your job is to figure out how to structure them in an interesting way. And of course, that's not the problem in the commercial sector. They got to find the objects in the first place. And if you go look and see how they used to find functions in the first place, the task is quite similar. There's a whole interviewing, scripting approach to mapping things into what has to get done. The difference is we don't throw away function anymore. We keep that function or that behavior. They used to throw it away because all they wanted was the data model. And then you can apply all kinds of new function to the same data model. So we've been working on a methodology called object behavior analysis and design, and the first paper on that was published in the Communications of the ACM in September. And we're now doing tools for the OBA, and we do this all jointly with Sematech and Texas Instruments. And finally, of course, we've done a lot of effort on visual construction. The VisualWorks we're going to show you is actually a product that comes out of having done it 4 or 5 times before. So we've thrown away a lot of prototypes. We see a lot of things coming to market and we go, oh yeah, that was our first prototype. We remember that. And there was a reason why we threw it away. It's actually very easy to paint a screen and generate some code that executes that. But the goal we had is to, and sort of the cute title here is, maintain the objective of the technology for reuse. And a lot of what we've been trying to do in the Smalltalk world is make sure that when you have very complex structures, you can reuse from any part of those complex structures and plug them into any kind of complex structures. And the kinds of tools you have allow you to mix and match as you please. We've seen a lot of people be surprised when you have a bunch of objects and we decide to make a new superclass, and they're all going to be made subclasses of this common superclass, but there were lots of members of the class that already existed, and they all live and they all keep living, and we just essentially remap all that stuff instantaneously. And then we discover, well, even a lot of other Smalltalk systems file all those instances out, restructure, and then file them all out in again, and sometimes it's 3 hours later. So we sort of put a lot of time into worrying about being able to restructure carefully and quickly, and as part of that, shortening the development time. And obviously, reuse is about quality. And most people tell you, gee, reuse is about getting it done faster, when in fact, what objects are really about, and what reuse is about, is improving the cost of the long-term maintenance of your systems. Here in research, you don't worry about maintenance. You don't want to worry about maintenance. That meant you were successful, too successful, because somebody took you seriously. You shouldn't be doing that in research. You should be doing things that, when you do it, nobody's interested in. Is there any managers here mad at me? And I used to have this argument all the time. If you're not doing something that is risky and it's okay to fail, then in my book it isn't research. But in a product company where you're supposed to be making revenue, you're not supposed to be doing that. In the commercial sector, you're not supposed to be doing that. So what you're worrying about is whatever you build, you know is going to be long-lasting, and you know it's going to change. If anything, the commercial sector has finally learned is whatever they build is going to be wrong a couple years later. Not because they were wrong, but because the world around them changed and the needs changed. So now you have this interesting problem. I've created a world of new things by reusing a bunch of old things. When it comes time to make a change, there's two kinds of changes. One change is just maybe restructuring the new things I built. That's okay. But the other change is that we'll constantly maintain the reusable assets. We will improve the quality of them. And what everybody out there believes is that the quality of everything you built will be infinitely better over time because it's going to be benefiting from the improvement in the quality of the reusable assets. Well, there's one flaw in this. As I improve my reusable assets, new reusers will certainly benefit. But what about the guys who were already reusing? How do we know who they are? How do we propagate that change? We did case studies on 32 very large projects, and 90% of the reuse going on was cloning. They were just copying from these libraries and then changing them helter-skelter and basically ignoring where they came from. Well, that means the long-time quality is not going to persist. So there's a fairly major maintenance problem out there, which you have to worry about if you're worried about the life cycle. Now, most of the reuse that happens in an object world happens either because we're going to reuse the external characteristics, which in a graphical environment means what the screen looks like, or we're going to reuse functionality and some aspects of the external characteristics, or we're going to reuse what I call genetics. That is, everything about you, however you grow and changes, your hair gets grayer, my hair gets grayer. It's sort of that genetic inheritance. And so you get a closer and closer, tighter and tighter coupling of how change should propagate. And the challenge to the designers for new systems based on effective reuse is to plan for how change should propagate over time. Now, if we're going to use visual construction and we're going to be able to benefit from reuse, then we have to think about just what does it mean to reuse those three aspects of the system. We're going to be able to express by painting and express through some kind of interactive dialogues or wiring exactly how we're going to build our application logic and how things will be dependent. But I want to make sure that I can choose how tight the coupling is so that I can predict the change, propagation that happens. So I'm going to skip some slides because we're going to show them online. And I'm just going to tell you quickly what's in VisualWorks and what you're going to see in the demo. The support for visual reuse then comes from there being a painter, which is what everybody does. You have this notion of a canvas, you bring it down the screen, you make sure that you have a lot of tools to handle the layout and the positioning and the decorating that needs to happen. Then there's a definer, because there's different layers, remember, on that network of different kinds of users, and some of them aren't going to want to have to see any code, and some of them want to see code that's scripting, and some of them want to see all the details of the coding. So you want to be able to have this canvas you paint, which is your external characteristics, will be linked into your database and your data model through an application logic or model, And that application logic can be partially generated. And the way we do that is to think about there being an application model which represents the general notion of how all the dependencies work between all the parts of the visual interface, and David's going to show you some of this, and then be able to subclass and specialize that. The product manager on VisualWorks who came out of Informix was very familiar with the Informix database tool book. And so he went through the book and he said, I want to do everything in here, all the 4GL activities, never writing any code at all. And he built a subclass of our application model that just understood that default behavior. And every time you build something, you just said, make me an Informix model, and everything then would be generated. Now, we don't generate code. What we do is generate user interface specification, which becomes part of the model. So for the painting, we generate the specification. For the application logic, we generate the code. And then we have a builder that, when it's ready, generates the actual code. And for those of you who are familiar with the Smalltalk world, we had this factoring of models, views, and controllers, that is to say, information models, presentation, interaction. And we're basically generating what is fairly complex code and complex graphical transformation and layout code. David, you want to? So what David's going to be doing then is he's going to show you how, as an interface designer, he uses the painter and the definer to generate the specification, which gets you to start building a user application. That user application passes the models and the specification down to a builder, which passes through the look policies, because the specification says, I want an action button here, but depending on your presentation policies, am I host, am I Mac, am I my own invention, you get the actual thing that the end user ends up seeing. So I'm going to switch this off, right? Okay. And then we turn that on. Did you do that one? Yeah.
Okay, am I on?
Yeah.
Okay, first I'd just like to show a few of the applications that the product manager built, so you can see sort of the types of things people build. This is this finder that I'm interacting with is sort of a way to find all the things that have been built with VisualWorks. Oh, goodness.
That was a surprise.
Demo effect.
I don't know. It was working earlier. Left it in funny shape.
Okay, so this is a thing he built for tracking leads for salespeople. So we can go through and look at different leads and make notes about them. And look through things about different salespeople, that sort of thing. It looks like the kind of thing people build with HyperCard. Got his calendar sort of application. Okay, so let's build some stuff with it. You open up a canvas to paint on and get a palette of the widgets that you want to paint. And you can paint with action buttons and radio buttons. And it's got the normal selection and grouping and kind of things that you'd see in normal drawing programs. And you have alignment and distribute functions. Oh, did them the wrong way. Do that again.
It's hard to work and talk, David.
It is.
So it's a line on the vertical. On the vertical.
Yeah, vertical, right. The normal way I do it is Actually, there's keyboard shortcuts for everything, so I would just normally do it off of the keyboard.
We'll make those mistakes, right?
It's a lot faster. So you can bring out different kinds of widgets and place them and interact with their properties. So we have a good Xerox style, sort of a property sheet interface to these things, so I can select the widgets and see what properties that I have to fill in, so I can give this group box a label. Move it around. Another one of the tools, let's see, Canvas Control, would allow me to turn on a grid, set the grid for whether I'm gridding it in X and Y, put a fence up around it so I don't have to be careful when I'm dragging things around. I can just slam up against the edges. Let's get something with scroll bars. And from this I can preview different looks and feels. So we can look at sort of the OS2 CUA look or open look. Anybody like motif?
Yeah, I do.
Oh, good. And can I show this one?
Yeah.
Macintosh.
But don't stay there. It's the ugly way.
Okay.
Go back to Windows. It looks better.
Go back to Windows? Okay. It's a Windows machine. I guess that's the right thing to do. Okay, so actually let's build something and see how it all hooks together. So let's just have a simple number input field and a slider. And what I'll do is I'll name an aspect for this widget to hook up to. No. And say it's a number.
You have to apply it.
And I want the slider to talk to the same aspect. Set a range for it and step it by 5. And at this point I need to give it a place to live. So it's going to prompt me for the name of a class, which would be typically one of our application models. Oh. And it says, I've never seen that. Do you want me to go ahead and make a new class for you? And it gives me an opportunity to name a different class or make it a modal dialog, but it's the plain application model's what's wanted. Okay, there's another tool that I really want to use. This is sort of a control panel that lets me do pretty much all the useful things like aligning and distributing and spacing components. And I can also define things that need defining. So since I've been saying, all right, I'm going to hook up to a certain aspect, which we called aspect, it says it knows it needs that. So I say, okay, go ahead and write the application code for me, so I'll have something there of the correct type that will answer to aspect. And at this point, I'm ready to run the thing. And of course, it doesn't work.
What didn't you do?
I don't know. I'll have to go see.
David's giving a demo in front of an audience for the first time, so be nice. Go look at the property.
Oh, okay, I didn't.
You didn't say accept.
I didn't tell it that one
That
was
one was
aspect.
fine.
I didn't accept
Yeah.
it.
Now you can install and do it over again. Now you have to define it. You have to define it left to right. Say define.
Oh no, I didn't accept the type either.
Oh.
Okay.
Just now redo what he did, and now you can. All right, there it is. There we go.
There, at last. So it should do the normal slider and number value trick. And you can add a button easily.
Give it a name.
And close request is one of those things that already knows how to do, so I don't have to write any code. Now, internally, we make a lot of use of sort of active values, we call value models. And we have a theory that the widgets want to talk a simple uniform protocol to things that just know value and value colon. And application models tend to want to have a lot of state. So we sort of objectified the state as value holders. And if the application is interested in finding out that the value changed, it can register an interest in that. So we can write a little application code.
Say what you're typing.
Okay, I'm going to create an initialize method to hook up the registration of the interest.
So there's basically a declarative language in here for how you declare the dependencies and link up things. Some of them are automated and some of them you write. So part of that language is to say when things change, what to do. So you say what changed and then you say what message will be received and then you just do it. So what he's doing is saying whenever the aspect changes, come to this method and do something, and what it's going to do is print in a little transcript window. So now he's going to what's behind all VisualWorks is still ObjectWorks, and there's a little transcript window that he's going to print in. So you just open it up, and every time he moves it around, you see the numbers printing in the transcript at the same time. So it's pretty quick.
I wanted a carriage return in there.
When you give a demo, you have to. So of course, true to small talk, he's making changes to the code while the application is running. So you saw him do that for those of you who didn't know that works. Okay, you want to do the switch?
Yeah.
Okay. So there's actually three things. One of them was just quick and dirty, and there's a notion here of value models, which is if you're going to hook together two arbitrary things, then they're just not always going to know about each other. So what's being generated here are communication channels, and standard communication channels send messages, give me your value and take this value. But there's all kinds of adapters in here, much like you would adapt into the wall for various aspects, for agreeing on changes in protocol, changes in numerical ranges, and changes based on computation. The second technical thing to show you is how this visual reuse propagation works. So what I'm going to do is clean this up take out what he has. And yeah, I can leave most of this sitting here. And I'm going to build 4 applications very quickly. The first application, and I basically don't use the pop-up menu, so I think I'll be okay. I'm going to open up the property tool and let it sit here and give a property to this window. I'm going to call it the original. I see, you can hardly see as part of the problem. And then just apply that so I can remember which one is which. And then I'm going to drop on here just the button. And on this, this button then, I'm going to set its property. And its property is going to be that I'm going to ask to calculate something, calculate for the label. And the action will be do calculator. I'm just making this up. We can name any of the components. Now, one of the things is we can't show you all of the capabilities of VisualWorks, but VisualWorks, of course, is written in VisualWorks. So all of the things you're seeing where the window canvas changes to sub-canvases, where things become visible and invisible, where there's things being enabled like these buttons down here and disabled, all of that is programmable. So almost anything we can do that you can see and anything we can do visually, you can also have a programming interface to. So I'm basically going to just have that one action button here, and I'm going to install that. And the class, I'm going to give this class the name original. Now I'm going to learn to spell original. And I'm going to make it a subclass of the application model so it defaults to all that capability. And I'm going to store the specification in a canvas called Windows Spec, which is the default. And I'm happy with that. And now what I want to do is ask, do I have to define anything? And it says, no, you don't need to do that. But for the application as a whole, I need to define something. It's no specific. Oh, we're still in your, it still thinks that, David, does it still think it's the old guy?
See what properties are on action? You didn't accept it.
I did the same thing you did because I can't talk and drive at the same time. Oh, you're right. I didn't do it. I was busy talking to you. Calculate. Stop talking. Do calculator. And then say accept, right? I should have known because I couldn't see it, right? All right, so we'll close that out. And now I will install it again because I've changed the user interface, I've changed its image. Now I'm going to ask, is there anything to define? And it says, yeah, there's something called do calculator. So I say, okay, do it for me. So it's defined it. Of course, it's defined it to do nothing, so that if I open it up, it's going to sit there doing nothing. Now, what I wanted to do is actually to open up some application that was there before. So this is the first level reuse. And there's a whole bunch of, I can filter example classes sitting around, and one of them is this calculator example. I think there's also a mortgage calculator, M-O-R. No, you don't have one here, you have a loan calculator, so I'll use this guy. So I'm going to have this guy, when I say start him up, what I see is what you'd expect, a typical little calculator that 9, and if we're real lucky, 9 times 6 will equal 54. Usually Smalltalk works if it can do arithmetic. So we're going to use this calculator example. So I'm now going to go back to here and ask to browse, and it will show me the class it's defined and its actions in the calculator. Instead of doing nothing, I'm going to ask it to bring up that calculator example, and part of that protocol is simply to say open, accept that, and close this window, and come back now to the running application, which now opens the calculator. Okay, so as you'd expect. So that's going to be our first one, and that's going to provide us with something that we're going to reuse. So let me put this aside up here so we can remember what the original is and go get another canvas. This is such a teeny screen, it's amazing. Okay, so now what we're going to do is, each time we do it, we're going to take a canvas and we're going to put in a sub-canvas. So here's this sub-canvas. And now I'm going to come and get my property sheet. And I like to do it out of the properties here. And the property for the sub-canvas is going to be that I want to use original. And I want original's window spec. So I said there were 3 things you reuse. One is the external characteristics. So we're going to start out using just the external characteristics. And let me open this window up a little bit so I get some layout help. And I think the other thing I want to do is put on that sub-canvas just for show a horizontal scroll bar, just so we can see some differences and things going on. Maybe I'll make it a little smaller, and then that will cause us to be able to scroll through it. All right, and then I want to set the properties for the window, and I'm going to call this one first, as in the first reuser. Okay, and we'll apply that, and then close this down. And then we're going to install it. And this one is going to be called first. Same window spec, that's fine. Application model's fine. And we're done. So I can see if I need to define anything. And it says, yeah, you have to define do calculator because you didn't inherit anything. All you asked for was the visual interface. So I say, okay, define it. But I'm not going to have it do anything. So I'm just going to open it up because my point here is just to see it. And there is the working reuse. But of course, if I hit calculate, it doesn't do anything because I've defined it to be blank. Okay, but that's enough to show my point. When I go and change original, the issue is what happens to first. So that's the first one. Now let's get another canvas. Do the same thing again, make a sub-canvas. I've noticed something that's interesting. If I put this guy in the upper left corner, I'll have better layout. So I'm going to make that change to the original and install it. And just say OK. So now I'm going to this one, and I'm going to put a canvas in here. And then I'm going to go get my properties sheet again. Yeah, I always like this one because it reminds me. When I'm talking, I have trouble doing this. And now I'm going to go for original again. And I'm going to say it's the window spec. But now I'm going to say that there's a client. And I'm going to call the client orig. That's going to be good enough. And basically, by saying that I want, so there he is. But by saying that there's a client name, I'm saying I want what's in here to be an instance of the class original, whose name will be orig. And that way I'm delegating responsibility. So let me give a name to the label to the window as well. And that way we can keep track of it, and we'll be real clever, and we'll call it second. And we'll apply that. So that one has a label. And I'll close it. And so now we'll install that. And again, this time we'll call it second. We're almost done. Window spec is again, I'll just use the defaults. Defaults are fine. Okay. Okay, so for those of you who are object-oriented folks, you have to start thinking, when I change the original, what's going to happen to all these guys? Because we're going to test you. Now, do I need to define anything? The answer is orig. So I say, okay, do that for me. It's constructing everything I need. So I can just say open now. There's second. And I can ask for the calculator, and it worked just fine. Right? Let's make one change to second. Let's put a menu bar at the top. All right, so let's go back, and let's get the property tool up. And let's say that I want a menu bar at the top. And I'm just going to apply it. And now we'll close that down. Now I need a special tool, a tool that lets me build menus. So I have a menu editor. And it's a little bit of a text editor. We've encouraged Dave to think he can do better than this. So what we're going to do is say, here's some actions. The action is going to be calculate, print. Maybe we'll have something called show, and we'll show hello, and we'll show bye. I'm just making things up. Right. We want to have the same one. Do, calculate, chore. These are the actions that'll happen. So, David, that's not right. It's just calculate. Let me do it. Don't confuse me. Right? And I'm going to build this. So here's what the menu is going to look like. It's either going to say calculate or print. It's going to show hello, goodbye. Or I could have a menu button that cascades things as well. So I get to rehearse what that looks like. I say, looks cool. Do it. Put it in second. I have to give it a name. We'll call it the menu bar. Okay. And then I can call it anything. And there it is. And I can come back over here and rehearse it and make sure I like what it looks like. That looks fine to me. So I go, fine, let's just put this away. And now I'm going to install that. And I'm going to call that seconds window spec. And so we're done with that one. So now if I say, do I have to define anything more? It says, I say, no, I've already done that, so let's get out of there. And now if I go browse and go look what's here, I'll see that I have an implementation for what it takes to do the instance, but I have no actions. And if I go and I open this up, calculate works, but nothing here works. For example, if I try to say hello, nothing will happen. Now, I've not given it any actions associated with the menu bar. So let me go back. Let me just go close all these things up. This is a very small screen, and the smaller it is, the better off. We have to keep it as clean as possible. So I'm going to go back to that menu editor. And I'm going to go load the menus from second, which is menu bar. It's the one I want. Let me see that again. Now, actually, the format is to put the actions in, like do calculator, show something. I'm just making things up. Say hello. Have to learn to type. And say goodbye. Say bye. So I'll build it again. So what I'm doing is saying for anything that's there, there's a message that will be sent to happen, and I'll apply that. And I'll leave it in menu bar, because I could have done something else. And I'm done, and close it up. Now there's a bunch of messages that if I teach second to understand, which I'll add actions. And so I'm going to teach it how to say hello, which is just going to put into the transcript. I'm going to say show hello from second. So this is going to be a good test for us to figure out whether we know where the show message is going to come from as I start making changes. So now let me open up second, and calculate, of course, is still delegated and works fine. If I say, the rest of them won't work, but if I say hello, let me show you what's going on down there. Bring it up. It says hello from second. Like David, I forgot to put carriage returns in, but if I keep doing it, it will just keep spreading, say hello, hello, hello from, okay? So now that works. Okay, so now let's do one more, and then we'll change the original. I said that you want to reuse the external characteristics, you want to reuse the functionality, delegate to existing things, but I also said you want to be able to inherit genetically. So this guy is going to have a subcanvas, and this subcanvas is going to be the same thing we had before, property tools. And it's going to come from original. It's going to come from the window spec, but it's not going to be an instance, so that's going to be fine. I'm going to apply that. And then I'm going to go to the window and give it the clever name of third. And I'm going to apply that. And then I'm going to add one more button, which is going to be the hello button. So we're going to have this hello button. And that action is going to be hello. The action is going to be say hello, so we have the same one, and we'll apply that. Okay? And so now we're going to install that as third. And now I'm going to do something different. Instead of saying I want to be a subclass of application model, I'm going to say that I'm going to be a subclass of original. So now I'm inheriting the genetics. I'll say OK. OK. And I asked now for third, is there anything I have to define? And it says I have to define do calculator and say hello. Now say hello makes sense since that's the new action. But I thought we inherited do calculator. Does everyone understand why it shows up as something to define? How many of you think you know about it? I know some small talkers here. Okay, you can override an inherited message, so it's giving me the opportunity to do that, but I don't want that to happen, so I'll turn it off. And we'll just go for say hello. And then what I'm going to do for the just this one button, I'm going to ask to browse to its method. And I'm going to say that what's going to happen is transcript show hello from third. Okay, carriage return, right? I heard somebody thinking whether I was going to do it or not. All right, so we got that one done, and I should be able to open it now. Calculate's going to work? Sure. That was inherited. Hello's going to work. Where's our transcript? Let me get it in top so you can see. I'm going to clear it. Oops, wrong button. Cancel everything so it's clear. And come here and hit the low button. Everything's too big. There. There's hello from third, right? Okay, we got them all working now. Now I'm going to go back and change the original. So now comes the test. I'm going to make a change here. What I'm going to do is I'm going to add a button. And the button I'm going to add is going to be the hello button. And that's one thing I'm going to do. The other thing I'm going to do is show you one more tool. So I'll use this. The label is going to be hello. The action is going to be say hello. And we'll apply that. And then I'm going to get a pretty tool for you. See, there's a bunch of positioning tools. I can make any widget relative to any other widget, relative to the edges, or fixed in space. Or I can get the coloring tool and color things. And these are what we call read-apply tools. So it's actually reading what's here and seeing its color, and then I can choose to apply it. So I'm going to make it a motley green. Does it show up motley green? Yeah. And then apply that to hello. And then I'm going to turn off the read, go to calculate, keep that green, and apply it. And that way they both get to be the same color. Or I can say, no, I don't want to do that, make it yellow. All right, we'll change it. So we get just some coloring so you see the tool that's there. Okay. And I'll install that change to original in the same canvas, or we won't get the inheritance. All right, so now, of course, something has to be defined here. I have the button selected. I want the whole thing selected. It wants to define, do calculator I'm happy with. We just have to define say hello. Now I'm going to browse to it. Now, when I browse to something, it will show me in the hierarchy where else things are, and that will help me because then I can just copy it and I won't forget. Where are these buttons? I won't forget to do that. What's happening with the buttons in me is that I've been using a Mac and I've been completely tainted by Larry Tesler's idea of one button, and so my fingers are having problems. Second. All right. Oh, excuse me. This is original, and we'll be cheating if I don't get it right, huh? Thank you, guys. All right, so we fixed that. Now, let's see if it works. If I open up the original, there he is. Hello. Let's make it pretty so I can see it on the screen. I'm going to shut down this guy. We don't need him anymore. And we don't need him anymore, so that'll be fine. And see, we don't need him anymore. So we get some room here. All right, and we're going to clear this for the big test. Cancel. All right. Hello from original works fine. All right. Now let's go look and see what the other guys do. Here's our finder. I'm going to filter the finder to look at user classes and make it easier for me to find what I've done. And I want first. There's first. So I'm going to start him up. Okay, so here he is, the color change. Now the button's in there. And of course, what's going to happen? Can't possibly work, right? You're going to get an error. Because all we inherited with first was the external face, all right? We could have done that with a cut and paste, or we could have just done it so we inherit. If I cut and pasted, I clone it, I wouldn't have seen the color change and the button change. Of course, this is the one that has the nice scroll bar and that we can scroll around in it. So that's first. We'll put him over here. Now let's go get second. S-E. These are list widgets, and they allow you to do some searching. So here's second. Now second was delegating, right? So if second's delegating, whatever he knows how to do, it does, and it's coming from original, right? However, here's hello, and it's coming from second. So everybody knows the right thing to do. All right, so that was a decision about how the change should propagate. Now let's go get third. Okay, now start that one. Here's third, and we have both of them again. Now what's going to happen? When I push the green hello, what's going to happen? From what? Danny, from original? From third, of course, because it's overridden. He knows say hello just because we implemented it here. I always fool people because I did the subclass before I did the superclass. All right, so I did it the other way around, right? Sorry, I've done this all the time. Okay. The issue here is to do some planning on the propagation of change, and then you get to test your class and see if Danny was just teasing all of you. There's one more thing that's interesting that we've done, which is not part of the product yet, but given a lot of language designers and UI designers here, I thought you'd find interesting. So David's going to show you. One of our goals here is that we're really moving into the 4GL market. And the 4GL marketplace, surprisingly, will start with these little systems, and then the language will be defined like this. Very simple declarative languages. And then they kind of get bigger and bigger and bigger. It's interesting to watch those manuals grow. But what you want to be able to do is program declaratively. Say, do this, do this, do that. And that's what we do graphically. We do it visually. We do it programmatically. But we want to be able to wire together the relationships between all kinds of parts of an information model declaratively. And of course, to do that, you have to do it with constraint language. So our value models allowed us to build a very simple constraint language as an aspect of that. So we're going to take 5 minutes to do that, and then we'll be done.
Okay, this is the classic Fahrenheit to centigrade example, where the only interesting numbers are 32, 0, and minus 40. I think that's all the Fahrenheit to centigrade examples good for. Now the code for this, when you get into programming active values that communicate by way of dependency, it's easy to get into a situation where you get into dependency loops, or you have to write 2 different versions of the code depending on what it is that's changing, and make sure that you don't start looping, so you have to test the other guy's value before you assign into it to stop it. So, in playing around with constraints, what you really want to do, or playing around with Fahrenheit to centigrade, you just want to write a little bit of algebra, which is sort of the definition of the relationship between Fahrenheit and centigrade. And notice the object C is a number holder. And this is, I think this is sort of a low-tech kind of constraint. It works with simple algebra. It doesn't do simultaneous equations. But since messages to an object can be dealt with appropriately, arithmetic messages to constraint objects create other constraint objects, and messages to numbers that don't take numbers as arguments fail the primitive and do double dispatching, saying, all right, I'm an integer and you said you wanted to multiply, you better know what to do. So the constraint object response to that is to build a right-handed constraint as opposed to a left-handed one, which will propagate it one way or another. So basically this is the entire Fahrenheit to centigrade application. It's just that definition.
And a typical 4GL programmer can write that, whereas what you'd have to write otherwise were all the conversion routines going back and forth and structuring all the messages, and there's just no way they're going to keep track of all of that.
That was pretty easy. It starts 4 something, but I don't know what it is. 4GL.
Oh, I'm sorry. Fourth generation languages, 4GL, yeah.
Thanks.
Playing
So
around with
the examples are focus and progress and natural.
That phrase.
Yeah.
So it's the angle conversions. And the only object that gets created here in this case is an angle that's a number holder. And then when the machinery that hooks up the specification object to the application, it asks it for a binding to be resolved. Radians just sends radians to this number object, which doesn't compute radians, but it creates something that will when asked for its value. And sines, just works on radians.
Right.
And let's see, there's one last one. Not that one.
Loan?
Yeah, got to remember what I
Just
called
type
it.
L. Oh, constraint loan.
Anybody want to borrow money? So I can borrow that and say, eek, I can't pay that. Go back the other way. And the code basically just says these are the number objects that I want. Make this a little bit bigger. Make it a little bit bigger yet. These little displays. Okay. So the constraint that's being created is this formula that came out of a book. Now, I added some syntactic sugar to this pretty quickly, so I could make these statements that look like arithmetic, but it's really constructing constraints, stand out, because I think it would be unfortunate to never be able to trust simple arithmetic, looking at arithmetic, not knowing whether it was actually doing arithmetic or making some kind of constraint thing. So in the long run, I think we'll actually come up with a constraint browser that lets you write constraint code. That's sort of where we're going.
Right. So this is sort of where we're going to start adding a declarative layer to Smalltalk so that people who can copy formulas out of books, and the kind of applications we've been showing you are really what most people build when they're doing a lot of these really simple access the database, put things on the screen type stuff, and we're trying to make them do that quickly. So that's what we wanted to show you today. And sorry it ran so late. It's 5:30 already, but if you have an urgent question, please ask it now.
Yeah, I think that Adele would be willing to stay after the formal end of the forum for questions.
Sure, if you want to turn off the tape, it's easier to answer the questions.
Do that. We're going to be thanking you very
Thank
much
you.
for